Okay, hi everybody. So consider the infinite sums with this formula. Okay, so this means, we're thinking in our head 1 over 1 to the p, 1 over 2 to the p, 3 to the p, 4 to the p, and forever and ever. Of course, we cannot do that, right? We cannot actually add up infinitely many things. So instead, we're thinking about this is equal to the limit of a sequence of partial sums. And now we could actually do this, like we could do this piece. That's the third partial sum. We could do this piece, that would be the fourth partial sum. Okay. Okay, so now for what values of p are these limiting values of the limiting values of the sequence of partial sums known by explicit formulas involving other well-known constants, in particular pi. So what is the limiting value for p equals 2, for example? So first, just to put this in context, this is going to be a function from the complex numbers. It's going to take an input that we're going to name p, and the output is going to be named zeta of p, okay? Or in other words, this is the function zeta slash zeta. And what's the formula for zeta of p? Well, zeta of p is this sum, where the sum is taken over the ends, these things. P is fixed. When we choose the input p, it's fixed, and what varies is this n, this little n. Okay, and remember the positive numbers. This is my notation for, just because we can't plug in 0 to the p. Well, I don't know. Anyway, it starts at 1. Okay. Now, okay, so I have to answer the question, for what values of p are they known? What's Apery's constant, and what is the limiting value for p equals 2? So I'll say zeta of 2 is pi squared over 6, supposedly. Okay, we didn't prove that, so you can believe it if you like. Zeta of 4 is equal to some rational number and powers of pi. And in fact, not just zeta of 4, but also zeta of 6 is known. Zeta of 8 is known. Zeta of 10 is known. Zeta of 3 is not known. Zeta of 5 is not known. Of course, zeta of 5.1 is also not known, but for particular integer values, in particular an even positive integer, this is, this sum, where, let's call it this positive integer p or whatever, is equal to some rational number times some power of pi. Okay, so people think that's interesting, right? So you may think that's very interesting. Also, what is Apery's constant? Well, zeta of 3, literally 1 over n to the third, equals, well, nobody knows what it equals. So at least somebody named Apery proved it's not equal to some rational number. For like 3/4 is an example of a rational number. So just like we were able to prove that the square root of 2 is not some rational number. Well, also somebody was able to prove this about zeta of 3. Okay, so yeah, so this is zeta of 3 is Apery's constant. And yeah, did I answer everything? Here is the answer to, you know, what values of p are known to be related to other well-known constants. Well, in particular, pi is a well-known constant. This one is zeta of 2 in particular. And this is Apery's constant. So I did that one, and that one. Okay. These are just good examples to know, so you know some examples of what could happen, right? Because then you sort of know what's going on. You at least know what could happen, what couldn't happen, what's known, what's unknown, you know, what's an open mathematical problem. Open problem means nobody has solved it yet. Okay. So these are good things to keep in mind as you keep learning more math and really learning what math nobody knows.